All right, here we go. Related rates, day 4, assignment 4I. So I'm going to try to kind of pick up the pace in this video so it's not super long. So if you don't hear me talking or if I'm blazing through something, ask me the question in class. I'd be happy to help you out. But I just kind of want to get this video out of the way, kind of in a quick pace. And again, this is day 4, so none of this should really be that new. All right, here we go. A cube. Device is melting, so I'll say this has a side length of x. The side of the cube is decreasing at a rate of 2 inches per minute, so dx dt is decreasing at 2 inches per minute. How fast is the volume decreasing? So what is dv dt? How fast is that decreasing when the side is 3 inches? So the volume of a cube is its side squared, or cube. So dv dt is equal to 3x squared dx dt. The question is ultimately asking what is dv dt? So I better have all those other pieces, which I do. So that's a 3x squared dx. Negative 54. The top is a volume, so that's going to be inches cubed. The denominator is time, which is minutes. Two small planes start from a common location at the same time. Hold that right there. One flies east at a rate of 300 kilometers per hour. The other flies south at a rate of 400 kilometers per hour. And notice how that's, I know it's going down, but the length is increasing, so it's a positive number. The length is increasing. Okay, how fast is the distance between them? I'll call that L, changing. So what is dl dt? All right, that is the question. So, after 2 hours. All right, so what else do we know? Okay, so in 2 hours, the x, if that's kilometers per hour, would be 600 kilometers. The y, again, in 200, that'd be 800 kilometers. And the specific length at that point is a squared plus b squared is equal to c squared. So this would be at 1,000 kilometers at that moment. So how is the distance changing? So again, this is the same thing as saying a squared plus b squared is equal to c squared. All three of these are changing. So this is what? 2x dx dt, 2y dy dt, 2l dl dt. All right, and so that is my setup, and I am solving for dl. So I usually don't do this, but I'll do it right now. I'll do one cleanup step. So I just divided out the 2L. And so notice if I divide, I can, everything happen to have 2. All right, so this numerator is x. X times dx plus y times dy divided by L. So dl dt is equal to 500. The length is in kilometers. The time is in hours. That's what it is. So the length is increasing between those two planes at 500 kilometers per hour. Circular a circular puddle shrinks by evaporation and decreases in its radius at 10 centimeters per hour. So the r dt is getting smaller by 10 centimeters. How fast is the area shrinking when the radius is 1 meter? Ooh, tricky. 1 meter is the same thing as 100 centimeters. All right, so the area of a circle, area is equal to pi r squared. And the ADT is equal to 2 pi r dr dt. And they want to know how fast is the area shrinking? So the question is, what the heck is the ADT? That's the question. And so plugging and chugging, the ADT is equal to 2 pi r. R is 100. dr, negative 10. So that's negative 2,000 pi. The top is area, so that's centimeters squared. And the bottom is time, which is hours. Now you could do this exact same problem in meters if you so wished. And so that would be what, 0.1 or 1/10 of a meter if you really wanted. That would be 1/10 of a meter per hour. If you were so inclined to do it that way, then that would change up your limits. And so just for argument's sake, I'm going to multiply in that pi. And that is negative 6,203.1853. Okay, so just for argument's sake, in case you needed to get a decimal answer for some reason. Okay, again, I know I probably did this weird in a different video, but I'm better now, I swear. So a 2 meter tall man is walking towards the street light. So this is his feet right here. So he's walking towards the street light at 1 meter per second. So notice that length is getting smaller, so that would be -1. Street light that is 6 meters high. How fast is his shadow? I'll call this very specifically a shadow S. How fast is his shadow shortening? So what is ds dt? All right, so let's go big triangle. S is to x plus s is equal to the little triangle, which is 2 is to x. Cross multiplication, 6s is 2x plus 2s. 4s is equal to 2x. 2s is equal to x. All right. And derivative. So 2 ds dt is equal to dx dt. And so ds dt is equal to, so dx dt, -1 divided by 1/2. That's s, which is length, so that's meters, over time, which is seconds. we've got a ladder leaning against a building. Okay, a ladder is 20 feet long. Notice how that length will never, ever, ever, never change. If the bottom of the ladder is sliding away from the building horizontally at a rate of 2 feet per second, so the X is lengthening at 2 feet per second. How fast is the ladder sliding down the building? So what the heck is dy dt? How fast is the ladder sliding down the building when the top of the ladder is 12 feet from the ground? All right, so the only thing that I need to know is what is that instantaneous x at that moment. And so that is going to be a squared plus b squared is c squared, so that's 20 squared minus 12 squared. And that is going to be 16 at that instantaneous moment. All right, so let's go ahead and set this up. Jesus. Try that again. X squared plus y squared is equal to 20 squared. Again, that 20 doesn't move, it's a constant. So upon this derivative, this is 2x dx dt, 2y dy dt, and this is going to be equal to 0. The question is, what the heck is dy dt? Then, so that would be a subtraction of 2x dx dt divided by 2y. So 2's can cancel. All right. So this is negative x times dx. Try that again. Negative x times dx divided by y. No. Let me try that one more time. So, negative x, which is 16, there it is. I'm sorry. Negative x times dx divided by y. There, that looks a little bit more real, right? Negative 8/3, that is, what is y? Y is a length, so that's feet per time, seconds. AKA negative 2.666. We got conical piles now. Conical pile of sand is formed. Conical pile of sand is formed at a rate, so that's a changing volume. dV dt is positive 12. The volume is getting bigger. If the radius of the base is always 1/2 the altitude, so the radius is always 1/2 the height. How fast is the altitude rising? What the heck is dH dt when it is 6 inches deep? So volume is equal to 1/3 pi r squared h. I want to keep all the h's and get rid of all the r's, so they kind of help us out really. Don't have to get tricky with this. So r is the same thing as saying 1/2 h. And so this is multiply n, that's 1/4, so this is 1/12 pi h to the third. All right, so the derivative time, dv dt, multiplied by 3, dH dt. So this question is asking for what is dH dt. So that would be multiplied by 4, divided by pi and h squared. All right, so the numerator is 4 times dv divided by pi, I'll worry about that later, h squared. So this is 4/3 pi on bottom, 4/3 pi, and so height is in inches, time is in minutes. So divide by pi. This is the same thing as 0.4244. All right. Oh, this one's kind of tricky. A road and a railroad track cross at right angles. A car is going 60 miles an hour crosses the tracks 10 minutes before the high-speed train traveling at 90 miles an hour. All right, so the car is 10 minutes before the train. How fast is the distance between them? 10 minutes after the train. So the car crosses the tracks 10 minutes before the train starts. So the train starts to go. After 10 minutes of the train, which would mean 20 minutes for the car. Okay, so this is the car, this is the train, and this is the distance between them. Okay. So it's 20 minutes for the car, 10 minutes for the train, and they're going at these speeds. Okay, so here we go. The train, okay, dt, different type of T. Train, okay, you get the idea. So the train, what is the train moving at? The train is moving at 90 miles an hour. What is the length of that train? So the train is 10 minutes, which is 1/6 of an hour. 1/6 of an hour at 90 miles an hour. So that's 15 miles beyond the point. The car is going at 60 miles an hour. Again, it's getting longer. And the current car location, again, is 20 minutes. So that's 1/3 of an hour. 20 minutes, 1/3 of an hour at 60 miles an hour. So that's 20 miles beyond the location. The instantaneous L at this moment. At this moment, what the heck is L? And that would be what, 15 squared plus 20 squared? 25. Currently, that is at 25 miles between them. All right, let's do work now. So this is c squared plus t squared is equal to L squared. 2c dc plus 2t dt equals 2L dL. We are solving for, what is this question asking for? I think it's what's the length? How is the length between them changing? Real quick. Yeah, how fast is the distance between them changing in minutes? All right, so the distance between them, how fast is it changing, is the dl. So this is, again, 2c dc, 2t dt, 2L, and open simplify it too. All right, here we go. C times dc plus t times dt divided by L. The lengths are in miles, and the times are in hours. So miles per hour, 102 miles an hour. Oh man, that's a wrap.